to the first. This is ready queue. You can see here it has a queue header. A ready queue header contains pointers to the first and the final process in the queue. Each PCB includes a pointer field that points to the next PCB in the ready queue. So we must know that in the ready queue, actually what is in the ready queue? It is not the process. It is the process control block of each process in the ready queue. And also I already emphasized that the PCB is the most important data structure for operating system to manage all the processes in the system. The system also includes other queues like this diagram. When process is allocated the CPU, it executes for a while and eventually quits, is interrupted, or waits for the occurrence of a particular event, such as the completion of an I/O request. Last section, I told you that the process state, it is waiting state. So we have waiting queue, of course. Just now we already told you ready queue. So all the processes that are in waiting stage formed a waiting queue, waiting queues. So like this picture. Here we have waiting queues here, okay? So suppose the process makes an I/O request to a shared device, such as disk. Since there are many processes in the system, the disk may be busy with the I/O request of some other process. The process therefore may have to wait for the disk. The list of processes waiting for a particular I/O device is called a device queue. Each device has its own device queue. So like this picture, we have magnetic tape unit 0. Of course, this queue is with no process. We have also magnetic tape unit 1, this queue, and we have disk unit 0, this queue. We can see that it has 3 processes are waiting for this I/O device. Okay, and as for terminal unit 0, we have 1 process waiting for this device. So this is a waiting queue. And also we know that as for waiting queue, there are maybe there are many queues according to the waiting reason. Okay, the reason. So a common representation of process scheduling is a queuing diagram, such as this. Okay, each rectangular box represents a queue in this picture. Each rectangular box represents a queue. 2 types of queues are present. We have waiting queue and we have ready queue. And the circles represent the resources that serve the queues. Okay, this circle. And the arrows indicate the flow of processes in the system. A new process is initially put in the ready queue. It waits there until it is scheduled for execution. That means we say it is dispatched the CPU by scheduler. Once the process is allocated to the CPU and is executing, one of several events could occur. The first process could issue an I/O request and then be placed in an I/O queue, such as just now I gave you the example that waiting for disk operation. Okay, so put into I/O queue. The second may be the process could create a new child process and wait for the child's termination. So here, waiting for child executes. And the third, the process could be removed forcibly from the CPU as a result of an interrupt and be put back in the ready queue. When interrupt occurs, so it will be put back into ready queue because the CPU is scheduled to the interrupt service routine. Okay. In the first two cases, the process eventually switches from the waiting state to the ready state and is then put back in the ready queue. Okay, I/O require when the I/O operation that the process is waiting has finished, the process will be put into the ready queue. Okay, when the child process finish its execution, the parent process waiting for its termination will be put back into ready queue, waiting for the next scheduling. Okay, for next time to be allocated CPU.